Let me ask you, if you know Kubernetes but do not have monitoring, logging, and security in place, you are running a production cluster blindfolded. And one day, maybe not today, maybe not tomorrow, something will break. Performance will tank or pods will get compromised. And you have no clue what happened or why. Kubernetes won't save you. Kubernetes only schedules containers. Production reliability comes from what you build around Kubernetes. Hi, this is Shivam. This is the second video of the production tooling series. Today, I will show you exactly what you must learn after Kubernetes with demos on my local kind cluster, including Kubernetes Dashboard. So let's head on to the demo section. So this is my local cluster. I have one control plane node and two worker nodes. Let's go ahead and we'll create a deployment. I'm not going into much details of this deployment as I have discussed this already multiple times on my previous videos. So the kind is deployment. The name of the deployment is CPU Hog New. It has one replica. It is running a BusyBox image and it can request 100 MB of CPU and 100 MI of memory. Let's save this and we will apply this deployment. So our deployment has been created. Let's check the pods. It says CPU Hog New pod is up and running. Now let's head on to the Kubernetes dashboard. As you can see, I am on my Kubernetes dashboard and in default namespace. So if you click on this namespace, you can see I have multiple namespace and currently I am in my default namespace. As you can see, this CPU Hog New pod is consuming lot of CPU and lot of memory. So this is the first reality check. Kubernetes doesn't automatically tell you, hey, your CPU is being eaten. DevOps engineer will have to monitor it. Either they create alarms for it or someone should be present all the time to monitor the dashboard. So let's look at this pod. So currently I am inside my pod tab. Let's click on this CPU Hog New pod. We will wait for this CPU and memory usage data to populate. So after 5 minutes of waiting, so this is what monitoring starts with. And you can clearly see that the amount of CPU and memory usage is pretty high. And you might be thinking, is something unhealthy right now? But here is the next plan. Monitoring tells you something is wrong. It doesn't tell you why it's wrong. And that's the job of logging. So let's head back to Git Bash. Now I'm gonna create another file called crash demo.yaml and I will copy paste a pod. So again, I'm not going into much detail as I have already explained it multiple times on my channel. So a quick recap. The kind is pod. The name of the pod is crash demo. It is using a BusyBox image. Let's go ahead, save this and we'll apply this file. Okay, our pod has been created. Let's check it and it is throwing error. So let's check the logs of this pod using kubectl logs and the name of the pod. So if you look at this, logs tells you the truth. When something fails, log tells you exactly what happened inside the container. Now let's switch to the dashboard. Let's refresh it and we can see we have 3 pods here and the crash demo pod, it is showing an error status. Now let's click on this crash demo pod and we will look at logs here. And if you look closely, it is showing the exact logs what we saw in our Git Bash terminal. So this log is the why behind what happened. Now let's delete the pod. I will use dashboard to delete this pod. So it says our pod has been deleted. Let's check it. Yep, our pod has been deleted. Now if I try to run the logs command again here, it's gone. Now here is an important thing. If this was production, your logs are gone along with the pod. So this means that if your pod dies, logs will disappear. So disappearing of logs is something what companies don't want. They always want to retain the logs for at least 30 days so that they can look into what exactly happened and why your application crashed. So the solution here is centralized logging. You can use Elasticsearch, that is ELK, and ship your logs to either Grafana or Kibana. Kibana and Grafana will give you a dashboard so that you can view the logs in real time. So the dashboard would look more or less similar to our dashboard here, which will display you the logs along with the errors and all other information. Now let's move on to the next section, which is security. Most people think Kubernetes security is just don't run as root user. Obviously, this is part of the security, but the real daily security is who can see what and who can do what. And that is achieved by RBAC, which is role-based access control. So to demonstrate this, I'm going to create a separate namespace using kubectl create ns command, and the name of the namespace is demo set. I'm going to switch my context to current namespace, that is demo namespace. So it says our current context has been switched. Now I'm going to create a service account called viewer. I'm using kubectl create service account to create my service account. It says service account has been created. Let's check that. Okay, our viewer service account was created 3 seconds ago. So a service account represents an identity for an application or pods inside Kubernetes so that they can securely interact with Kubernetes API. Similarly, I'm going to create a role for pods, which will allow the user to get list and watch the pods. So if you see here, I'm using kubectl create role command, and the name of the role is pod viewer, and this role will allow users to get list or watch pods. So the role has been created. Similarly, I'm gonna create a role binding. So if you see here, I'm using kubectl create role binding command to create a role binding called viewer binding, and I'm binding it to the role which I created earlier, that is pod viewer, and I'm attaching it to my service account which I created above. So it says our role binding has been created. Now, since we have created role binding and service account, let's go ahead and we will create a pod in our demosec namespace. I'm using kubectl run command. The name of the pod is hello. It is running nginx image. And container is running on port 80. Okay, it says our pod has been created. Let's check the pod. It says our pod is up and running. So one thing I forgot to tell you, that how I got my dashboard up and running locally on my kind cluster. So you can use this command to install Kubernetes Dashboard locally on your kind cluster. I will mention all these commands in the description of this video. So I'm gonna create a token for this service account called viewer. So just for the information, whenever you log into a Kubernetes dashboard, you need to generate a token. So I have generated the token. Now let me open my browser in incognito mode and let me try to log in to the Kubernetes dashboard using this token which I generated here. So it says sign in. Now let's try to switch namespace. As you can see, I can only see one namespace, that is default, and demosec namespace is not available to me. This is production security, not trusting everyone with cluster admin. And since I have opened this browser in incognito mode, it is not giving me full control over the cluster. So if you don't learn RBAC, you will eventually create an environment where one mistake or one compromised token can destroy your entire cluster. So let's log out from here, and you can see that I was able to log in as viewer. So let me log out from here. Let me close this. So in real production, you also need admission policies. These are like gatekeepers. You also need runtime detection like Falco and network policies to deny by default. This deny by default means Kubernetes will restrict users from blindly accessing all the components in the cluster. So here is the thing. Kubernetes is just an engine, but production needs a full car. For example, for monitoring, it needs Prometheus and Grafana. For logging, it will use ELK, Elasticsearch agents, and Kibana Dashboard. For security, it needs RBAC, policies, scannings, and runtime detection. For delivery, it needs GitOps and Helm. And most importantly, for networking, it needs ingress, certificates, DNS, and policies. If you skip any of the above, you are not building a platform. You are just deploying containers and hoping for the best. And hope is not a strategy. If you have reached this point in the series, you have learned Kubernetes. Congratulations. Now you need to learn production because Kubernetes doesn't fail you in production. Your missing tool does. If you want, comment stack on this video and I will build a full series where we turn this cluster into a production platform, including monitoring, logging, and security. Till then, keep learning.